Hello everyone. In today's lesson, let's look at page 8 of your chapter 7 notes, starting with 7.3 number patterns. So let's look at this activity, activity 3. The first 4 figures of a sequence are shown. Okay, so we have n equals to 1, then n equals to 2, n equals to 3, and n equals to 4. Okay, so that's T1, T2, T3, T4. Now let's look at the number of dots in every pattern. Over here we have 1 dot. Over here we have 6 dots. Over here, if you count the number of dots, we have 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And over here, if you count the number of dots, 3, 9, 12, 15, 16. Okay, so we have 16 dots over here. Alright, let's look at the pattern. 1, 6, 11, 16. 1 plus 5 is 6. Then 6 plus 5 will give me 11. 11 plus 5 will give me 16. So I have a common difference 5. Okay, so immediately I can start to apply formula, which is Tn equals to An plus B, where A is common difference, so that's 5. And then what is my B? That means the T0 over here, right? When n equals to 0, this would have been negative 4. Okay, because negative 4 plus 5 will give me 1. So my general term will be 5n minus 4. Correct? Okay, in order to help us see this pattern better, we can also use a table, right? So when n is 1, the term is 1. When n is 2, the term is 6. When n is 3, the term is 11. When n is 4, the term is 16. So over here, right, it's a simple plus 5, plus 5, plus 5. So basically pattern 1 is telling you that every term is formed by plus 5, plus 5, plus 5, plus 5, and so on. Okay, so how many plus 5s do you have? For n equals to 2, right? You have to add 5 one time. For n equals to 3, you add 5 2 times. When n equals to 4, you will add 5 3 times, and so on and so forth. Okay, so when n equals to n, right, basically the nth term, you have to keep adding how many 5s? Basically the number of 5s here will be n minus 1. Okay, because when n was 4, you added 5 3 times. When n was 3, you added 5 2 times. So for the nth term, you will add n minus 1 numbers of 5. Can see? Okay, so if you look at the column for pattern 2, they are doing something similar as well. Basically, for the second term, right, when n is 2, you only added 1 5. So it's 1 plus 5 times 1. But for n equals to 3, you added 5 2 times, which means it's 1 plus 5 times 2, right? Okay, to get the 11. And then when n equals to 4, you added 5 3 times. So it's 1 plus 5 times 3. Okay, so basically using this table method, right, they realized that, oh, you can sort of slowly see the pattern and then come up with your nth term, which is 1 plus 5 times n minus 1, because you have n minus 1 5s, right? That's what you found in this first column. So it's 1 plus 5 times n minus 1. Okay, associating it again with pattern 3, right, you will have 1 plus 5 times 1 minus 1. The 0 is 1 minus 1. Okay, so to get the 1 over here, it's 1 plus 5 times 2 minus 1. Then this, when n equals to 3, it will be 1 plus 5 times 3 minus 1. When n equals to 4, it is 1 plus 5 times 4 minus 1. Right? Because 4 minus 1 is 3. There are 3 5s. So 3 times 5, 15 plus 1 gives you the 16 over here. So you continue doing the same thing, you will still get 1 plus 5 times n minus 1 for the nth term. So basically all these are different ways of deriving the same nth term that we already found at the start. Okay, so if we simplify this, right, we will get Tn equals to 1 plus 5n minus 5, which is 5n minus 4. Same as what we got earlier over here. Okay, hence find the 20th term. So you sub in n equals to 20, you will get 5 times 20 minus 4, which gives you 96. Alright, so this is how you find the nth term using a table. Let's look at the second question, which has got to do with square numbers. Okay, so in the first square, you have T1, right, has 1 square, T2 has 4 squares, T3 has 9 squares, T4 has 16 squares, T5 has 25 squares. This one is easy. Basically, look at the number here, the number of the term itself, and then look at the number of squares it has. Basically, 2 square will give you 4, 3 square will give you 9, 4 square will give you 16, 5 square will give you 25. Of course, 1 square is 1. Okay, you are looking for the nth term, it will just be n squared. Okay, so Tn equals to n squared. That's it. Very good. Moving on to the next page. Let's look at the triangular number pattern. Alright. So, in the first term, we have 1 circle. Second term, we have 3. Third term, we have 6. Fourth term, we have 10 circles. Okay. So, over here, it'll be a plus 2. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. So there is no common difference, right? It is not like a plus 3 plus 3 plus 3 plus 3. The difference keeps changing. So in this case, you might have to draw your table to find the general term. So let's look at a pattern. We want to associate this 1 with this 1 here, 2 with the 3 here, 3 with the 6 here, and 4 with the 10 here. Okay, so you realize that 1 times 2 will give you a 2. 2 divided by 2 will give you a 1. Does that work for the second one? 2 times 3 will give you a 6. 6 divided by 2 will give you a 3. How about that one? 3 times 4 divided by 2 will give you the 6. 4 times 5 divided by 2 will give you the 10. So basically, the number itself multiplied by the next number, that means n multiplied by n plus 1 divided by 2 will give you your nth term. Okay, so the nth term is basically n times n plus 1 over 2. For triangular number pattern, I suggest you remember this formula because sometimes they might test you on this. Okay, it is quite common. Alright, let's move on to the next page, practice 3. So it's quite fun to have diagrams given, right? And this question is even more fun because it told you to draw figure 4. Okay, so there's all these tiling patterns formed by using white and grey tiles. So let's look at the first one. Figure 1 has 1 white tile and 1, 2, 3, 4, 5, 6, 7, 8. 8 grey tiles. Okay. Figure 2 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 grey tiles and 2 white tiles. Figure 3 has 3 white tiles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 grey tiles. Okay. So figure 4, of course, should have 4 white tiles, right? And how many grey tiles? Yeah, it's 14 grey tiles. Okay, because it's just a plus 2, plus 2, plus 2, right? Okay, so let's just draw. You can use a ruler to draw. I'm using my stylus, so it's not going to be so nice. Okay. I'm going to divide it into 3 because everything has 3 rows, right? And then this one, 2, 3, 4, 5. I have 4 white in the middle. And then I'm going to start shading this border over here. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I have 14 grey tiles and 4 white tiles. Okay. Part B says, write down an expression in terms of n to represent the number of grey tiles in the nth diagram. So they are not concerned about the white tiles, right? Because obviously the number of white tiles is just the figure number itself. But they want you to find the number of grey tiles. Okay. So since this is a common difference kind of question, you know the common difference is 2. So immediately you write 2n. And you just have to find, oh, how many grey tiles were there in figure 0? Figure 0 should have had 6 grey tiles. Okay. So it is 2n plus 6. That's it. Hence or otherwise, find the number of grey tiles in the 100th figure. 2 times 100 plus 6, sub in n equals to 100, you will get 206. Easy peasy lemon squeezy. Okay, next question. Sequence formed by using layers of marbles. Figure 1 has 1, 2, 3, 4, 5 marbles. Figure 2 has 1, 2, 3, 4, 5, 6, 7, 8 marbles. Figure 3 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 marbles. And you can see it's a plus 3, plus 3, plus 3. Common difference makes our life happy. Okay, plus 3, plus 3. So obviously I need to have 14 marbles in figure 4. Okay, how do I know how many marbles do I have on top and, horizontally and vertically, right? You see for figure 3, right, there are 3 here, or rather 4 here, and 4 here, and then 3 in the middle. Then figure 2 has like 3 here, 3 here vertically, and then 2 in the middle, right? So same thing for figure 4, gonna have 5 vertically, right? 1, 2, 3, 4, 5, and then we're gonna have 4 in the middle, 1, 2, 3, 4, and then 5 vertically down again. Okay, so let's count whether we have 14 over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Very good. Okay, so figure 4 is drawn. That's part A done. Part B, represent the number of marbles and find the nth term, right? So nth term will just be 3n because common difference is 3. And then figure 0, I would have how many circles? 5 minus 3, I would have had 2. Okay, so my 0th term is 2, right? So it's just 3n plus 2. Done. Part C, hence or otherwise find the number of marbles in figure 28. So T28 equals to 3 times 28 plus 2. The answer is 86. Okay. Very good. Moving on to the next question on page 11. Okay, now we have series of patterns formed using dots. Draw the 5th pattern. This one is easy. You can see that for the first pattern you only have 1 dot. For the second pattern you have 4 dots, but it's formed by forming a square with 2 dots on each side. Okay, then the third one is just 9 dots. Okay, and the fourth one is 16 dots. So 4 dots here, 4 dots here, etc. So this is like the square number pattern, right? So over here you need to have 5 circles per side for the 5th pattern. And then you just draw, 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 draw. Of course you draw nicely until you form a nice square. Okay, there should be 25 dots. Okay, so find the number of dots in the 7th pattern. Of course in the 7th pattern you will have 7 square dots, right? So that will be 49 dots. This one is very easy to see.